Hello, class. This is going to start our recorded lectures for section 3.3, which talks about evaluating trigonometric functions using the right triangle approach. The idea with regards to the calculations are we're going to mainly focus on sine, cosine, and tangent. And remember in the last section, we talked about sine is the opposite side divided by hypotenuse. Cosine is the adjacent side divided by hypotenuse. And tangent is the opposite side divided by the adjacent side, all dealing with this right triangle approach to the calculation. And so let me show you this right triangle here in the slide. And so the strategy and the concept for these calculations is that we're going to again think about the zero angle being the positive x-axis. And when we generate these right triangles, the angle that we're going to be using for our calculations is the smallest angle from the x-axis to the hypotenuse. And so when we do these calculations, you'll see that the y-axis is always going to be the opposite, or the y value. And the x-axis is always going to be the adjacent, or so the y value is associated with the sine, and the x value will be associated with the cosine. And that's what we have down here with regards to opposite absolute value y and adjacent absolute value of x. So here's how we have this set up. And again, let's talk about sine, cosine, and tangent first. So first of all, by our definition of hypotenuse, at least the hypotenuse can never be zero, because we're always going to have at least some x value or some y value. Even if you have 0 degrees, you're on the x-axis. The y value will be 0, but the x value will be something. And for example, at 90 degrees, the x value is 0, but you still have a y value. So that's number one assumption. Number two assumption is the hypotenuse is always positive. As you can see from Pythagorean's theorem, we have to take the square root of the two sides. And both those sides are also squared. So all the numbers are positive. So again, by definition, the hypotenuse is never 0, and the hypotenuse is always positive. So with that, here's how we define the 6 trig functions. The sine is the y value divided by r, which is the hypotenuse, and the cosine is the x value divided by r. So remember, r is always positive and it's never 0. So sine and cosine is defined for any angle. But all the other ones, you could see we have either an x or a y in the denominator. For example, y over x is tangent. And so tangent could be undefined when the x value is 0, because we can't divide by 0. And you can see all the other ones are set up that way as well. And so after we go through maybe an example or two, you'll be able to kind of see what I'm talking about with regards to that. So let's go to the next slide. So again, very important. Hypotenuse cannot be 0. It's always positive. Tan could be undefined when the x value is 0. And cotangent, cosecant are undefined when the y value is 0. And again, we'll kind of show you that. So I think it's time to get to the whiteboard. So if we take a look at the whiteboard here and we draw a triangle. And so let's draw this triangle here where we have an angle of 90 degrees. And so basically, let's say that it goes up where this point here is x equals 0, y equals 2. So in this case, our x value is 0. Our y value is 2. And so what is our hypotenuse? Well, remember, we calculate it this way. And so when one of the values are 0, you get 0 squared plus 2 squared equals square root of 4. And so you could see that r also equals 2. So when we go back to the definitions of the trig functions, we know that sine of our angle is always y over r. And so in this case, it's 2 over 2, and that would be 1. You can see those are the same. Cosine of theta is x over r. So in this case, it's 0 over 2. And it's okay if you have 0 in the numerator, right? 0 times any number is 0. 0 times 1/2 would be 0. Well, here's a tricky one, right? So now we have tangent. So what does tangent equal? Well, tangent equals y over x. So what do we have for this one? Well, the y value is 2, but what is our x value? 0. And you can't divide by 0. So by definition, we call this undefined. And so that's those are how that works. So you can walk through the other ones, of course, and see what they are. But let's do this one all together. And so cotangent of theta, in this case, would be x over y. And so this one is x is 0 and y is 2. So cotangent is defined, and that equals 0. Secant of theta, that is opposite of cosine, so that's r over x. And you see this is the other one that's not defined, so you're going to get 2 over 0, and that equals undefined. And then the last one is cosecant. And so cosecant is r over y, and that one's also defined, which is the inverse of sine, right? So that would be 2 over 2 again, and that answer would be 1. So this is kind of how we walk through these calculations. And so this works in not only the first quadrant and on all the axes, but it also works in quadrant 2, quadrant 3, quadrant 4. And we'll talk about how to get those set up as well shortly. So another thing that is important, and I kind of warned you in the last lecture or two, is the understanding of the quadrants and what values of the angle that you are in the quadrant, and also what is the sign of the x and y. And I think you can see y now, right? So r is always positive, right? So if you think about quadrant 1, that's going to be between 0 and 90 degrees, or where this is the 0, and the positive x or y-axis is 90. And so between 0 and 90, both the x value and the y value are both positive. So sine, cosine, and tangent are all positive numbers. When we go to quadrant 2, we're going to be between 90 and then down to the minus x-axis, which would be 180, or pi over 2 to pi in radians. And here the x value is negative because we're on the left side of the x-axis. So that'll imply cosine is negative. And remember, tangent is x over y. No, y over x, excuse me. And so if one of those are negative, tangent's also negative. But remember, y is still positive, so sine will be positive. Here we have both negative between 180 and 270 in quadrant 3. In this case, sine and cosine are both negative, but tangent has two negatives, right? The numerator and denominator are both negative. So in this case, tangent will be positive. And then when we go to quadrant 4 here, the y value is negative between 270 and 360 degrees, and the x value is positive. So again, the opposite of quadrant 2, where sine is negative here, cosine's positive, and again, tangent's negative because one variable is negative and one variable is positive. Again, remember, the radius or the hypotenuse is always a positive number. So let's take a look at another example here. I'm going to do this one on the whiteboard. So for this calculation, I have it set up this way, where we have, this is the positive x-axis here, and we have a line going out to right here. And so this would be x equals minus 3, y equals 4. And we're dealing with this total angle. So when you do these calculations by hand, what you're going to be doing in the calculations is the right triangle always gets made to the x-axis. And it will be the smallest angle, because when you do a right triangle, the right angle is 90 degrees and the other two angles have to be less than 90. So in this case, when you do this calculation, this is how you make the right triangle. It always goes down to the axis. And so you'll see that we're going to give you some lookup tables shortly in this section. But in the calculation that we have here, this point here in the x-axis is minus 3. And this point up here in the y-axis is plus 4. So this height is 4 units, right? And this length here would be 3 units. So what is r? So that is the hypotenuse that we're dealing with. And so r, and this is strategically set up, would be minus 3 squared plus 4 squared. And you could see that's the square root of 25. So r equals 5. So remember, we're in quadrant 2. So what quadrant 2 implies is that the y value is positive and the x value is negative. So when we do these calculations, you expect a positive sine, a negative cosine, and a negative tangent. So let's do them. So sine of theta in this case is y over r. And so in this case, it's 4 over 5. Cosine is x over r. And so in this case, this would be minus 3 over 5. And so you see where our negative comes in this case. And tangent, theta, is y over x. And so this would be 4 over minus 3. And you see we have 1 minus. So that would actually equal minus 4 over 3. So that's how you would calculate the 3 main trig functions. And if you want the other 3, you just kind of flip everything. I'll leave that to you. Again, in my life, these are the only 3 I've ever used. And you'll see that these end up being the most important with regards to that. So I'm going to stop this lecture and continue on another lecture on talking about how to calculate the reference angles for these calculations.